The following is Summer 2009 Math 263elact College Test 2 number 8. Find the maximum volume of a rectangular box with 3 faces on the coordinate planes and the vertex on the first octant of 3x plus 2y plus z equals to 6. First, we need to define the function we are about to maximize in terms of x and y only. Okay, what do we want to maximize? We want to maximize the volume. The volume in terms of xyz will be xyz. Okay, let's take a look what we are trying to do here. Let's say this is the first octant. This is x, y, z, and you have a plane. Now you want to find a point on that plane that later on give you the box. Okay, now this point here, the vertex of one of the box will be on that plane. Okay, will be on that plane now. But because the question requires you to write the function that we need to maximize in terms of x and y only, then I will write this. I will solve for z, and this will be xy times 6 minus 3x minus 2y. Okay, in other words, this is the function we are trying to maximize in terms of x and y only. Is 6xy minus 3x squared y minus 2xy squared. Okay, that's the function we are about to maximize. Now on xy plane, this line here is given by 3x plus 2y equals to 6. Right? Now that's on xy plane. Now, this is the thing. So why do I need to find the xy plane? That way we can see what is the domain we are working on. If this is x and this is y, then this will be 2 here, this is 3. Okay. Now then, we want to maximize this volume. We then do the gradient of v. That is equals to the factor of 6y minus 6xy minus 2y squared. That's for the x component. When you do the partial derivative of v respect to x, and then the second component, when you do partial respect to y, will be 6x minus 3x squared minus 4xy. Now we need to set this gradient to be 0. Okay, when it is maximized. Now notice that this volume here, the volume of the box, will be maximum when it is positive, right? We want this to be positive, but that implies x will not be 0 nor the y be 0, which implies later on the c also will not be 0. Let me write it down. The c will not be 0. Actually, we can say more, because it is in the first octant, then all three x, y, and z should be strictly positive. Now, once I set this vector to be equals to vector 0, then it implies the first component, 6y minus 6xy minus 2y squared equals to 0, and the second component should also be 0. If I continue, I do factoring, I will have 2y for the first one, 3 minus 3x minus y equals 0. And the second component, so if I factorize the x, I will get 6 minus 3x minus 4y equals 0. Now, from here, you see that I can say directly that 3 minus 3x minus y equals to 0. Why? Because for sure the y is not 0, right? Because the y is not 0. Right down there, because the y should be not 0. Should not be 0. Likewise, with the same argument, the second equation now, because the x will not be 0, then it must be the second factor that is 0. Right? Because the x not be 0. Now, if I continue from that equation, system of equation, then I basically have 3x minus y equals to, I think I should say 3x plus y equals to 3. And then 3x plus 4y equals to 6. Right? Now, but if I subtract this equation, I will get negative, negative 3y equals to negative 3. So y equals to 1, which if I plug into either one of the equation, you will see that the x equals to 2/3, and therefore the z, which is 6 minus 3x minus 2y, that will be equal to 6 minus 3 times 2/3 minus 2 times 1, that will be 2. Okay, so the volume will be maximum when the x is 2/3, the y is 1, and the z is 2. Okay, and the volume will be the product of these three, right? That will be 4/3. Okay, now this is for summer 2009 math 263 at East LA College, test 2 number 8.